Okay, well, maybe we'll get started, and then as people come in as well, we can always catch people up or answer any questions. So thanks everyone today for joining us for our webinar on CRIS, which is the Climate Hazard Risk Information System for Prince Edward Island. This webinar today is really going to focus around some of the recent enhancements that we've had to the platform, but also just context and background on what it is existingly as well. So, uh, as we go through this, here's just a quick agenda to show what the day is going to be or this 1 hour. First, we're going to just set a little context on the types of flooding and past events on PEI. Then we'll go into CRIS and chat first about the existing features. And then just recently, as of Monday, we'll chat about the new features that we launched onto the platform. And then finally, we'll chat a little bit about accessing and applying CRIS. And then at the end, we can go through some questions if anyone has them. So if you do have any questions, just let us know, and the chat can be a great option for that as we go through. And then my colleague, as well as Crystal through Climate Sense, who we want to thank for helping us host this today, we'll take a look and we'll answer them at the end. I just also want to acknowledge that the webinar is being recorded today. We might distribute it afterwards so that everyone has it and can share it amongst themselves. So, what is CRIS? CRIS, as I mentioned, is the Climate Hazard and Risk Information System. And really, it's an online mapping portal that allows you to access different data on climate hazards and information in Prince Edward Island. So there's three main data sets within CRIS, which are accompanied by a lot of supporting data and reference data. But the main ones are coastal erosion, coastal flooding, and inland flooding. And we also just want to note that CRIS was co-developed by the government of Prince Edward Island, which I should have introduced. My name is Matt McNeil, and I work with the Department of Environment through the government of Prince Edward Island, specifically in climate adaptation. And then I'm joined here by Dr. Xander Wong from the University of Prince Edward Island, who has been extremely influential in creating the CRIS platform. But also, we want to thank the Government of Canada for their support on creating CRIS. So the CRIS platform was originally created with funding from Housing, Infrastructure and Communities Canada, and then these recent enhancements were supported through funding from Natural Resources Canada. So just so we're all on the same page, these distinctions between coastal and inland flooding is something that we want to make clear to everyone. So coastal flooding is really flooding that happens along the coast, and this is primarily a result of sea level rise and extreme weather events that cause high waves and storm surge. So this would be something similar to what we saw on the North Shore during Hurricane Fiona. And then inland flooding is, or you might also hear it referred to as pluvial flooding, occurs when intense rainfall cannot be absorbed into the ground quickly enough. And this is especially present in more urban environments where we see a lot more hard infrastructure, be it pavement or concrete and things of that nature. And it can also be an issue in the spring when we're seeing sometimes like rain events in the spring or spring thaws, but the ground itself is still frozen. We can see that flooding in that circumstance as well. And then I have a couple just videos here showing, and the reason that I show these is really to show that these events and these climate hazards are present on Prince Edward Island now and in recent memory, and with climate change could potentially get worse. So the first here is on the left, an example of coastal flooding that we see in North Rustico during post-tropical storm Fiona in 2022. And then the other video is the Holland College parking lot in Charlottetown. And this video in particular is from 2021, which happened as the results of remnants of Hurricane Ida. And then finally, erosion is also a climate hazard on Prince Edward Island that we are seeing more as well. So this is an example in Fee and Shore. And erosion can be gradual in nature or episodal, which is when we see like large erosion in a particular event as well. So you can see here that it was very significant. And then finally, just before we dive into really what Chris is, context on timelines. So we have had coastal flood maps on Prince Edward Island since 2021. These were originally launched through a platform called CHIP. And that also included ranges. And then in 2024 is when we launched this CRIS platform. And this included island-wide inland flood maps, as well as the coastal flood maps, as well as flood depth information. So not just how far inland we could see floodwaters, but how deep we might see them. And then also that erosion data. And then finally, the reason we're here today is the enhanced version of CRIS, which we added 9 main new features to, and we'll chat about that through the presentation. So I'll pass it over to Dr. Wong, who will chat through the existing features and then also the new features.
Thank you so much, Matt. Can you hear me well?
Yeah.
Great. Yeah. Thank you so much, everyone, joining us. My name is Andrew Wong. It's great to work with Matt and his team in the provincial government to, continually, improve CRIS. And today, first, I will quickly go through some of the existing features. Just for some of you, if you're not familiar with the existing version, I will just provide a quick summary, and then we will spend most of the time to look into new features. Yeah, for existing CRIS, one thing we have is the inland flooding. And this is really to look at, the flooding areas which will be caused by heavy rainfall. So we have considered the current climate conditions and future climate conditions, and we used 4 return periods, like 10-year, 25, 50-year, and 100-year return periods. So these are commonly used return periods like insurance company or other engineering professionals are using to really assess flooding. So we consider both current and climate. Next one, please. Yeah, so in terms of how do we generate pluvial flood map for PEI, we actually use the two approaches. For the whole island, we use island-wide model. Basically, we set up 100-meter resolution and with 20-meter mesh refinement for the whole island. And then for some of the municipalities like Charlottetown, Summerside, and Stratford and others, we actually use a very high resolution model, which is 10-meter with 2-meter mesh refinement to generate more realistic flood maps in urban areas. So certainly we have a very detailed technical report to describe all the details. If some of you who are interested to learn more, I certainly encourage you to go to CRIS platform. There's an About Us page. You can look at more details about the technical modeling aspects. And we also have coastal flooding. For coastal flooding, if you have used the CHIP platform before, actually these are basically based on the coastal flood map generated by CHIP. So we incorporate them into CRIS, and plus before CHIP only provides flood extent. But for CRIS, we also include flood depths so that you can really measure, what is rougher water depths in some of the areas. In terms of flooding scenarios, basically they are the same. We have high floods and moderate high and moderate low and extreme flood scenarios. And as Matt mentioned, another data set we have for CRIS is coastal erosion. Through CRIS, you are able to explore the coastal lines for the 5-year periods. You have 1968, 2000, 2010, 2020, and 2022. So you can switch them all off through CRIS to see where they are located. And based on these coastal lines, we also calculate the coastal change by both distance and rate. So that you can click on individual coastal line segments to look at these coastal changes. This will provide some useful information for you to understand the coastal hazards, specifically coastal erosion in different areas across PEI. Through CRIS, for some professional users, certainly a lot of people would like to download a lot of data for further analysis. We do offer this function, which is called reference layers. So you can load all the reference layers like coastal flood elevation. This is basically coastal flood extents, or you can turn on and turn off coastal lines for different years. and also many other, reference layers like municipality boundary, planning jurisdictions, watershed boundary, wetland boundary, and many others. Most of the reference layers, you actually can download them directly from Chris, except the property boundary, which you need to contact the Provincial government to get that. Yeah, and okay, so next okay, I think we're good, Matt. Yeah, yes. Next, we're going to just jump into the new features for Chris. So these are something we have worked over the past year with Matt and his team to really, add a lot of new features to make sure Chris is more, user friendly. So yeah, next. So this is a summary about the new features we have included through this new version of Chris. And first, we have launched added the Mi'kmaq place names. And for each feature, I will, in the next few, minutes, I'm going to go through each features to talk about the details. This is just a summary. We also have 2023 oblique coastal photos along with the whole PEI coastal line and historical flood maps. These are specifically for 2022 Fiona and 2019 Dorian. And we also display the flood isolated areas. And for coastal properties, we have further added property level flood statistics. You can look at the coastal erosion rate and coastal flooding for those coastal properties. And we also included historic ortho imagery so that you can turn them on to look at different periods, what kind of changes we have experienced. And we also have dynamic coastal areas to really show where we typically have sand dunes. These are areas which were subject to constant changes in coastal processes. And we also provided a rainfall and return period calculator. This is to really help people understand this is really based on the information provided by Unui and particularly we have included 40 Mi'kmaq place names in PEI, and they will be loaded by default when you open Chris. And but you can toggle them off. There's a small button in the right bottom toolkit. Sometimes you can, if you can certainly toggle it off or toggle it on. And once these icons are displayed, and you are able to click on each individual icon to display its Mi'kmaq name, pronunciation, English name, meaning, and we also have short pronunciation video to tell you how to read this name. So this will automatically load it when you click on each icon. And we really appreciate that the work done by Unui to get it done, and I think this is really helpful, even for myself, to learn how to read each name. Yeah, next please. Next one is oblique coastal photos. These are the photos that were taken in 2023 from a small aircraft flying near the coastal line of PEI. So again, you can toggle them on or off, which is there's a camera button to the right bottom toolkit. You click on that, we will toggle on all these locations where we have collected oblique photos. And once those photo icon is on display, you can click on each individual icon to display all the photos. And here, this is an example showing how it looks. And you can, click, next or previous button to switch photo, or you can also click, next point or previous point to switch locations. And if people are interested in look at more details, you can even download the photo to look into more details about that. And I think people can also drag, zoom in or zoom out through this photo viewer with Chris. Yeah, next please, Matt. And third one is historical flood maps. As I mentioned, we have generated two flood maps for two historical events, including Fiona in 2022 and Dorian in 2019. Now you can just add them, load them through Chris by selecting historical events as a hazard type, and then you will be able to select which event you want to load to the flood map. So these maps are generated by using a mechanism which is called a hindcast with flood models, and they are driven by observed rainfall data and also high water marks which we collected after these two events along the coastal lines. So when you load the historical maps, we also will automatically add the high water marks associated with each event, particularly in those coastal areas. And this will provide you some information, especially as a reference for you to understand what the highest watermark in those areas. Next, please. Yeah, flood isolated areas. This is really to show, those areas or buildings where that, which are likely to be affected by flooding. And in the current version of CRIS, we actually provide three types of, isolated areas. We start with buildings. We basically look at those buildings which are, either directly flooded. Basically, your building is kind of sitting in the flooding zone, or there might be some buildings which are not directly flooded, but the access road, you may lose access, to the main road because the main road is flooded. So we kind of use network analysis based on building locations and also road networking PI, and we use all the fire station as targets to really check if you can have access to those locations during flooding. And these are based on each individual flooding map. So different flood map, you may have different scenarios. So these are really, this is really to look at buildings, how buildings are affected. Plus, we also look at those areas, even though some areas which we don't have any buildings, but potentially might be like like a park area or some areas. If people go there, we can also provide some information for them to make a decision in case of emergency. And yeah, and you can switch, click on icon to switch individual flood isolated areas under different scenarios. And people can also download the flood isolated areas for further analysis if they are interested. Next, please. Coastal property information. This is really to provide more detailed information about coastal erosion and coastal flooding for those properties which classify as coastal properties. And in order to view that, first you need to load the reference layers specifically to turn on the property layer, which will show all the property boundaries. After that, if you click on those properties which are classified as coastal properties, and we will pop up a new information sheet which summarize all the details, provide all the details about this specific property. And certainly you can request coastal hazard assessments through government if you want to learn more details. Next, please, Matt. Yeah, high resolution also imagery. This is so far we have incorporated all the available high resolution also imageries provided by the provincial government, and we have 2020, 2010, 2000, 1968, and 1935. So these also imagery, they are added as base maps to CRIS, and as you can see from this slide. If you go to base map, drop down list, you are able to see all the also images. You can simply select which area you want to display, and then we'll load the also imagery directly. And one thing I want to add is that you can also download the high resolution also images by tiles. There's a download button in the bottom right toolkit. And you click on that, we will automatically show all the tiles across PI. and you can click on individual tiles to download the high resolution also imagery. But I want to mention that the data set is huge, so it's only recommended for those people who are professional, who has certainly some GIS skills to handle the data set. Otherwise, I personally encourage you to simply use Chris to load the data. Next, please. And we also have dynamic coastal areas. So this is simply a layer to allow people to toggle on or toggle off to show where we have these kind of coastal dynamic areas, which typically will be sand dunes or coastal barrier islands because they are subject to dynamical changes even seasonally or annually in PEI. So we basically highlight those areas so that in these areas the coastal erosion rate may be not accurate because it can be changing area. So it's really to provide a reference layer for people to identify where we have these kind of dynamic coastal areas. And again, we offer the data for people to download if they want to do further analysis. Next, please, Matt. Yeah, rainfall IDF curve calculator. I think this is the purpose of this function is really to help people like to understand. Sometimes, for example, if you see maybe I received like 100 millimeters of rainfall maybe in the next few days, you may ask, oh. I just want to check, is this like a 100 return period event or 50-year return period event? So, actually the purpose for our IDF calculator is actually to provide a tool so that people can use this tool to estimate the return period. Or you can also select a return period and we can tell you maybe in Charlottetown or maybe in Summerside, what is the average rainfall amount for a 100-year return period event. So I think it's kind of useful for people to easily understand the links between return periods and rainfall intensity or amount. So with that example, basically this IDF calculator is integrates all the weather stations maintained by Environment and Climate Change Canada because they have long-term observational data. They also provide a future climate change scenario, data under different emission scenarios. So with that, you can click on each individual location. For example, the station in Charlottetown is located in the airport. So you can click on that location, and you can ask this calculator, to maybe provide the rainfall amount for 100 return period event, or you can just select rainfall amount for a specific duration, and ask the calculator to tell you what is the return period for this event. One thing I want to make a note is that we have noticed that for all the stations, in the context of climate change, it is very likely to see like the current year, for example, here you see 25-year return period event in the current climate is likely to become 10-year or 5-year return period event in the future. So which means all these kind of extreme rainfall events are likely to get more frequent in future climate scenarios. Next, please, Matt. Okay, elevation contours. This is based on the elevation data collected in 2022, and our colleague from provincial government, Andrew Clark, and he kind of generate these 2-meter elevation contours for the whole PEI, and then we incorporate this in PEI into the new version of CRIS, so that people can toggle it on or toggle it off to really display the contours. I think this is extremely helpful for people for planning purposes. And you can also zoom into individual locations and click on these lines, contour lines, to display the specific elevation for this line. And once that pop-up window is on display, you will see a download button, which allows you to download the contour shapefile for the whole promise of PEI. Yeah, next. All right, I yield back to Matt for the remaining slides.
Awesome. Thanks, Xander. Um, yeah, so just gonna chat a little bit about how to access and apply Chris, just very briefly. So, in terms of using Chris, this is just a screenshot of the platform, and I really recommend the best way to learn about Chris is to just go in and play with it. So, but just for context for everyone, this is what you'll see when you load it on a computer. You can load it on your phone or your tablet, but we do recommend because of the large data sets, usually a tablet or a computer would be best. And on the left here, you'll see the setting panel, and this is really where you change between those main data sets. So changing between an inland flooding scenario or a coastal flooding scenario, or now the newly added historic flooding scenarios. Um, and that allows you click the orange button to load the map. And then if you were looking into loading some of those reference layers, you would do so through there. Um, you'll also note there's a couple videos there, one on what flooding is, and then one on um, how to access and use Chris. And we have that in there really as a reminder in case anyone has confusion on Chris, but also just so that this platform can be really shared with anyone is our goal. We're trying to make it approachable and user friendly, similar to kind of a Google Maps. So that video can help if you wanted to share this platform with anyone else. And then the center here is really the map panel, and is where the information is shown. So this is kind of the Google Maps interface, if you will. And you can zoom in on certain areas, click on any of those features or there's those data sets with in the map. The top right is the legend panel, and this corresponds to those flood depths as well as the erosion distance. So you'll see here there's a bunch of points dotted around the coast. Those would, if you click on each one of those, will give you erosion data for that section of coastline. And then the bottom right is the toolkit panel. And here, again, really encourage you to explore and click around. But these have a number of those new features that Xander mentioned are toggled on and off through the toolkit. And that's where you would change base maps, etc. And then finally on the Chris portal, you'll see on the bottom there, this is just the title panel. So this shows what the map is displaying. So in this circumstance, it's showing the extreme flood scenario, as well as coastal change for the period of 1968 to 2020. So again, encourage you to load it up, which this is how you access it. So just go to princeedwardisland.ca/Chris, and through there'll be a link to launch the mapping platform. As I mentioned earlier, you can access it really through any device, but if you're loading reference layers or anything like that, we would recommend a computer or a tablet. Yeah. So in terms of applying Chris, really the goal with Chris is to increase awareness of climate hazards on PEI. And through doing this, it enables the public to view hazards at, let's say, a property of interest, and then also incorporate that data into decision making, both from an individual property owner perspective, but also perhaps from an organization or a community basis. And then also, we designed Chris to be open source, which encourages academics and professionals to integrate the data into their work. Anyone can go on there and download the data and manipulate it and study it from that perspective. In terms of using Chris, as I mentioned, kind of Chris was really designed to encourage people to make more informed decisions. And a couple of examples might be when purchasing or renting a cottage, you could look at Chris and see if it's in a flood zone or if it's in a coastal area, what is the erosion rate there? Is it really considerable? Uh, it also enables you, we often say in my group in climate adaptation that a risk becomes a hazard only when we put people or infrastructure in its way. So, if you're considering building on, let's say, a coastal property, building further back or building higher up might reduce that risk. And Chris can kind of give you some preliminary information on where those risks are. And then also, um, really, especially with the new flood isolated areas layer that Xander worked to create, uh, you can understand if access to an area might be compromised through a large storm event. Maybe the main road becomes flooded, even if your property is of a higher elevation. Um, and as we noted too, a great feature of Chris is the climate projection. So you can see what the risk is currently today, but also we can understand how that risk will change with climate change into the future. I also want to note that Chris really is a preliminary tool, so it does not take the place of a detailed engineering design assessment. So, if you were in a high hazard area, you could then think, if you are developing that area, to reach out to engineers and see and understand how you can combat that risk in that area. So that's really all for us. I know we're only a half hour into the hour, but we do have plenty of time for questions. So I know Crystal from Climate Sense, as well as my colleague Brian, have been in the chat. I'll just see if there's any questions, or maybe um, pause, let anyone kind of open up the mics as well. But yeah, we
Yeah,
have a
there's just one
question.
question in the
Yeah,
chat right now, and it's asking about, was the code developed in-house? And this is Eves that's asking this question.
it's probably a Xander question.
Sure. Yeah, I think I don't fully get it. Certainly, we kind of are you asking about the the code behind Chris or uh, yeah, absolutely. I think I developed all the the front end, the back end to make it reliable, and for the was and all the data we kind of host it. I think so far, except a property layer, which is not cannot be downloaded directly, but all the other data sets can be downloaded directly from Chris. This is right, as Matt mentioned, we want to make sure it's kind of people, if they want to get data, they can download data directly. Um, yeah, I think that's what we have done so far. But I would say, Sonny, there are a lot of potent functions we can improve or add in the future. If you have any comments or suggestions, we are very open to that. And like Matt from Prometheus side and myself, we are pretty open to for all the improvements. We want to make sure this is, uh, you know, um, you know, very much user focused. So that people can use to explore flooding and coastal hazards in PEI.
Yeah. And as Xander mentioned, both my email and Xander's email are up on the screen now, so we're very available to discuss anything in more detail. I do see a question from Karen Noonan, which was asking if flooding can be shown in real time during an emergency, and that isn't shown in Chris. Chris is kind of a tool that shows we can understand what the current flood risk is in the current flood plain, but during an emergency, it's not like a live flood
Yeah.
map.
Okay.
But the federal government does do a coastal flooding warning system, which they've implemented. So that kind of provides some of that more real-time notice if we're expecting a coastal flooding event.
Okay. Thank you.
Yeah. Um, we also have a question from Mike, which is, can you speak to the inputs into the inland flood model? Was it only DEM mesh, or was there additional data layers used in the modeling of depth and extent?
Yeah. Maybe Matt, I can speak to that.
Yeah,
Yeah,
absolutely.
sure. Yeah, thanks for a great question, Mike. Yes, so we consider many other input data for inland flood map. DM is only important. DM based on the 2020 um, DM data, and which is 1 meter resolution. And then we certainly need to consider land use, land cover, soil data. We also consider hydro network, road network, and when it comes to rainfall, you need to consider the rainfall intensity data, which is based on ECCC weather stations. We also use the coastal boundary condition, which is based on the cheap coastal flood map. So yes, these are, and we're also like some hydraulic structures in PEI like culverts, and in open areas, these are well is represented in our urban models. But for pluvial, for island-wide models, we kind of use approach which is called DM breaching, or hydro connection based on DM, and this is based on hydro network and road network, where you have this cross between hydro network and road network. Typically, you should have a current. So we kind of use that approach to cut through the DM so that the water can flow. And we actually have a very detailed report on the About Us page of Chris, and you can download that report to learn more details about all the technical details about the inland file map.
Awesome. If there's any other
question,
yeah, you go ahead, Xander.
Yeah, I think the next question is the code available in GitHub? No, we don't host it in GitHub at this moment. Next one.
I think Mike shared resources to a Natural Resources Canada mapping for emergency mapping as well. So if anyone wants to explore that, we have another question that just came in. Do these flood extents and depths take into account flood defenses like dikes or dams? A question for Xander. I don't know if PEI, unlike some of the other maritime provinces, I don't believe has an extensive network of dikes that like certain areas of New Brunswick has. But Xander, do the maps consider that? It would be elevation based, I suspect. Yeah.
That's a good question, but as explained by Matt, we don't consider that in our current inland farm for PEI because we don't have these kind of structures. So the main hydraulic structures in PEI are bridges and culverts. So bridges already reflected in the existing DM data. So our efforts were mostly focused on those culverts. So the culverts is really a major portion hydraulic structures in PEI. So that's why we kind of focused our efforts on these, but not for dikes or dams in PEI. This is very much context based. Yeah, so we don't consider that in current map. Yeah.
If we have any more questions, definitely go ahead and use the chat. But yeah, I would really encourage everyone to go to princeedwardisland.ca/Chris and launch the portal and just play around and explore in it. There's a lot of good information there as we went through. And I believe by being part of this webinar, you'll get a link to the recorded version afterwards as well in case you want to reference anything back. We'll give it a couple more minutes for anyone to ask more questions, but we're also available to chat by email if you have anything else. Maxim just was noting, Maxim is a partner through Natural Resources Canada who's been also very influential in the enhancements in the launching of CRIS. So really want to thank our federal partners as well on their support. We also have a question from Kelly. Do you know if insurance companies are using CRIS? I can't speak to specifically what insurance companies are utilizing, but I do know just generally that they do consider flood risk. And whether or not that's through the CRIS platform or other information that they have, I'm not sure, but it definitely is a consideration, I think. Also a note on the historic coastal lines. Yeah, it's a really great resource to see how the coastline has changed, as we saw particularly on the North Shore. As a result of Hurricane Fiona, there are some areas that have very extensive differences. And also, like the University of Prince Edward Island has been doing a monitoring program through peg lines, if anyone's familiar, for I believe about a decade as well. And they're doing some work this summer to share that information as well. So just you might see some kind of public information sessions on that as well being shared. Um, Aaron Nelson asked, how often will the oblique photos of the coastline be taken and updated on Chris? So yeah, as Xander mentioned, we have those photos that were taken from a low-flying airplane around the coastline of PEI. I kind of call it almost like the Google Street View, but it's from the air. These are the ones were taken, I believe, in 2023. We are currently flying this year as well to update and take photos for 2025. So we'll see an update on those. And then our intent, as noted through the policy recommendations that we have from the coastal policy recommendations that UPEI published, is to continue taking those oblique photos in a regular interval. So into the future, hopefully. Um, and then, yeah, we just have a link shown there about Chris in reference to a local business deciding to move locations as well to be outside of the floodplain. Um, yeah, any other questions? If not, but again, we'll stick around if anyone does have them. But I just want to again um, thank Dr. Wong and his team from the University of Prince Edward Island and the Climate Smart Lab for co-developing this with the province of Prince Edward Island. And then also again, thank the Government of Canada for their funding support for the creation and enhancement of CRIS. And please feel free to reach out at any point as you play with it. It's kind of the best way to know. And again, happy to answer anything by email.